All right. Back in the YouTube game with another one. Caeser Encryption, Python, Codewars. I think this one is spelled incorrectly on purpose because this is not your typical Caeser cipher encryption. It is a little different for those of you familiar with Caeser cipher. Here's what we got. You have invented a time machine which has taken you back to ancient Rome. Caesar is impressed with your programming skills and has appointed you to be the new information security officer. Caesar has ordered you to write Caesar cipher to prevent asterisk and obelisk from reading his emails. The cipher shifts letters in a message by the value dictated by the encryption key. Since Caesar's emails are very important, he wants encryptions to have uppercase output. For example, if the key is 3 and the thing to encrypt is hello, it equals that. If the key is 7, it equals that. Basically what this is a Caesar cipher where you do the shifting and then the results are always uppercased. So it's a little twist on the classic Caesar cipher. And for those of you who don't know what the Caesar cipher is, it's where you take a word or a string and you shift forward by a certain amount. You shift the letters forward. So an H shifted forward by 3, it's going to be I, J, K, because K is 3 past H. E will be F, G, H, and so on and so forth. And that's why the first 2 letters are K and H, because it is those 2 letters shifted forward in the alphabet by 3. So this one over here is shifted by 7. H shifted by 7 is an O. So that's what it is. You shift the letter forwards or backwards based on the value of the key. That's 30-second Caesar cipher, I guess. Maybe even less than 30 seconds. I'm not timing myself. But anyway, let's get in here and do this thing. We're armed with information, and now let's act on that info. So I want to make sure everything's the same case, first of all, because there's a test case in there that kind of messes with you where things are in different cases, and if they're not all lowercase to begin, it kind of screws up what I'm going to do. Obviously, there's many ways to do this, and if you do it a different way, the uppercase stuff may not screw it up for you, but for me, it do. I'm going to create an empty string to hold the encrypted message. Then I'm looping through the message because I'm going to process each character, because I'm going to encrypt each character. I'm going to take each letter and shift it. I guess, I don't know if there's negative shifts in this at all. I think they're all positive. Anyway. I'm going to do a check to make sure the letter is an alphabetic character, because if it's not, then I don't really know what is done. I think if it's, well, I have done this before, of course, so if it's not, you just, I'm just going to pass it along. I'm only going to mess with letters, because the only thing specified to do is with letters. So, all right, this is where all the magic is really going to happen. And this is going to be, there's going to be a lot to this. Some of this may not be necessary, but it's kind of, yeah, you know what? I'm just going to copy this stuff over. You guys don't need to really watch me type this all out. All right. So yeah, all the magic is happening on line 6. And what I tell people all the time is when you have a complicated expression like this, you read it from the inside out, mostly. So, taking a look at this, I get the ASCII value of the letter, the current letter, turning it into some number in between 97 and 122, because this is the range for lowercase ASCII. And then I add the key to it, whatever the shift is. So I add the key to it to make it, whatever the number is plus however long or however forward I need to move it. That's what I'm going to do. So once I've done that, I'm going to subtract 97 from it, because it's going to change it from this ASCII range to the 0 to 25 range, which is like the normal number range of the alphabet. A is 0, Z is 25. So I make that shift, or that conversion. Then I modulo 26, because I want to handle the possibility of a wraparound. Like, say your letter that you come up with is a Y, and the shift is 10. It's going to go past the end of the alphabet and wrap around starting at A. The modulo takes care of that wraparound so that it'll wrap around to the beginning of the alphabet again. So I'm not going into non-letter characters. And then the plus 97 is going to convert it back into ASCII from 0 to 25, back into this ASCII range. So I handle the wraparound, then I shift it back to the ASCII range so that it can then be converted back into a character so I can see what it is. And that's the last part here, the CHR. The CHR is a function that converts decimal to ASCII. So once I've done all my screwing around with it, I convert it back to character. Almost lost the word there. And then once all that's done, I take the uppercase value, or the uppercase version of this letter, and concatenate it to the string. And my else, it just says if this is not a letter, I'm just going to concatenate it as is. Like if it's a space or something else, concatenate as is. And that's all, folks. That's going to do it, really. You just return it. You've got your encrypted string. And this is going to pass as long as I didn't make any damn typos. Let's take a look. Not there, none there, none there. Looking good, looking good. Alrighty, folks, this is Caeser Encryption, Python, Codewars. Once again, this is it. So I'm good, you're good, and I'm out. See y'all later.